Hello there and welcome to this course on data analysis with polars. My name is Valentine and I'll be instructor. In this video, we're going to be going through this library, which is a data analysis library when it comes to Python. And it's much more similar to pandas. The only thing is that how it works is different. It works really well with large data sets. And it's built off differently from the pandas library, which is built off Python. Polars is built off Rust, which is one of those emerging languages that would be critical, especially when you're looking at performance level when it comes to just creation of applications. So Polars is an enhanced tool when it comes to data analysis that works really well with large data sets. And yeah, so this course will focus generally on how you work with Polars for data analysis. So let's get started. The first thing that you need to do is to go to the description section of this video, and you should see a resource link that should take you to a page that looks like this. Once you get here, you can sign in and then get to the practice notebook if you're an Afterwork member. But if you're not, you'll be able to get to the sample notebook that will just allow you to have access to the concepts that we're going to be going through. But there will be limited challenges. But the practice notebook has lots of challenges. So yeah, once you get here, just connect this notebook and you can save a copy and run the first cell to import polars. And we do that using the import keyword. So import polars as peer, just like how we would do with pandas. And in any instance where we see PR, we are actually going to be calling polars to be able to work with it and perform various data analysis operations. So the first concept that we're going to be learning is how to load and preview a CSV dataset. So assuming that we have this dataset that we have already stored in this location and we wanted to do some data analysis work, we would need to load it first. So we would need to use the read CSV function. There are other functions when it comes to working with just different data types or data sources using polars. This is just one example. And we read it just like how we would with pandas, and we just pass the URL. There's this particular parameter that we can set just to be able to ensure that we have a format, a CSV format that works best for us. So yeah, so we just load our data set into a variable and preview it using the print function as shown. So we use just the head function to be able to display the first 5 records. And you might note that when it comes to polars, the first record, the index we get an ID, so we don't get the indexes for technically for this particular case shown. Like, you know, when we print with pandas, it usually gives us all the indexes. But if you can also decide to just not work with the print keyword, which will give us a lot more of information, in particular to the data types for each and every column, and also the shape of that particular data frame. So yeah. Again, we are working with data frames just as we would with pandas, and you'll just realize a lot of the techniques are just sort of similar, and which is the same to other pandas alternatives that are a bit more efficient. So yeah, so once you have loaded, then you can be able to preview the data set. So here we're just getting the first 5 records using the head function, and you can use other functions such as the tail to be able to get the last one. Yeah, all right, pause the video and then work on the challenge. Something to note is that we're also going to be introducing a challenge, a series of challenges. So when it comes to working with data analysis, more specifically with Python, so you'll be able to be walked through, you'll be getting emails. So if you are really interested in just being serious about this track, when it comes to data analysis with Python, in the description section, you'll also see another link that tells you can be able to get a learning path that allows you to get an email every day about the tools that are relevant when it comes to data analysis with Python. So also you can have a look at that. Moving on, in certain cases when we're doing data analysis, we might want to display the column names. So if, for example, we have this data set here, we're not using the truncate rugged lines parameter, but in some cases we might want. So assuming that we have this particular um, data frame, which contains our data, and just contains farms data, and we wanted to get just only the column names, so we can display the column names as shown. So by just using the dot columns property or per columns property or attribute, just like how we would still with using pandas. All right, moving on, renaming columns in a data frame. So in some situations, we might want to change the column name so that we are able to work with column names that are easy to work with. So for example, if we have this data set and we preview it, it contains crop ID, crop name, region. By the way, something to notice that when we use the print keyword, we don't get all the columns displayed. But if we don't use it, we'll actually get all the columns. So here we can be able to see all the columns. But yeah, so I'll just use it. So it looks nice, but again, the objective is just to do analysis. So here, assuming we wanted to replace the column names with new column names, especially ones that have underscores between the words, then we can use the rename function, and we pass to it a dictionary that contains key value pairs. The key would be the original column name, and the value of that key would be now the new column name that we want. So we do that for the column names, and then we just we replace that, and we can be able to see that we have new column names. All right, pause the video and then work on the challenge. Moving on, in certain cases we might want to filter records. Maybe we want to filter for records and get records that have certain conditions as true. So for instance, if we have this data set, to be able to perform filtering, we would use the filter function. So here we would inside it specify the condition. So this is our first condition. We want in this column, PL column, region column, we want it to set our condition to have the value as not. So for records that we want to retrieve records that have region as not, and you set a second condition, season, which is the other column that we have as spring, and we store the output of that in filter df and print down the filter data set. So if you look at this closely, you should be able to see that we have region as north. But if I just remove the print keyword to be able to see other columns, let me do that. So you can see that spring for season is this one. We have spring as the value. So these records have these two particular conditions set. All right, pause the video and then work on the challenge. In some other situations, we might want to just filter columns, like filter, like specify only columns that we want for analysis. So in our situation, if we have this data set that again contains crops data, we might want to maybe select some certain columns. So we use the select function and we specify the columns to work with using a list. And then we can chain other functions like the filter function that we have just learned and set our conditions for the data that we will get. We want only for where the yield hands column is greater than 300. Then we display the filter data frame. All right, so pause the video and then work on the challenge. In some other situations, we might want to use aggregate functions in columns. So if we have this data set, which contains, again, farms data, we might want to just maybe perform some aggregate function on a column. So we might want to calculate the sum of revenue, the sum of expenses, columns. How we do that is that we just use the sum, we apply the aggregate function to the column, and we store the result in a variable, and we can display that variable as shown here. So here we're just using the sum aggregate function. We can use average or minimum or maximum, etc. In some other cases where we have unclean data or data that's tidy, we might want to perform some data analysis, such as maybe in this case we have missing data, which is null, as you see here. We might want to identify the missing values, like how many missing values are there within that particular data frame. So we can use the null count function that gives us an idea of the missing values in each column. Here I can just leave out, can just decide not to use the print function so that I can be able to display all the columns. Like you can see here in the harvested column, we have one particular missing value, yield per acre, one missing value, total yield, one missing value, and missing values, 8 of them. That's the column that's actually called missing values. Okay. Moving on. So once we have identified the missing values, so this in pandas, I think we usually apply it using is null, then apply the sum function at the end. It's like the equal bit of that. All right, imputing. So assuming we wanted to handle those missing values. So assuming this is our data set that we have. If we wanted to maybe fill in the missing values with a particular, maybe not, maybe something like not available. So for example, for the columns that that we are working with, let me just remove this so that we have more details about this particular data frame. So for this particular column, we might want to replace the missing values for the string data. So for columns that have textual data, we would replace that with not available, and columns that have numerical data would replace that with 0. So essentially what would happen here is that what I have said, like, missing values that belong to a column that has text values, we would replace those missing values with not available, and on the other side 0. Then we display the data frame with the appropriate data, with appropriate function, null count. All right, applying a custom to a column, so custom function. So in some cases, we might want to maybe create a new column, and then that new column would be as a result of a custom function. So assuming we have this data set that contains information about crops, and we wanted to create a new column that converts maybe something like kgs, let's say something like could be yield, which let me just display that so that I have that completely yield. So assuming we have yield here, and we wanted to get instead of tons, we wanted it to be in kgs because the other columns are in kgs. So we can define a function to be able to do that, just a Python function that returns the kg value of the equivalent value that is there in that column, or for the record that we want. And we just apply that function for that column that we have. So we take the function and we as an input, we give it to the column, and to give us now a series, the list of values for that column. And then we would add now this new column that we've created to the original column using the with columns function. And we set the name of that new column to be yield kg. And yeah, so that's it. And we display the updated data frame. So the approach here is slightly different from what we would do in pandas. We have yield at the end. All right, and you can note here we have int 16. These are just also just data types. Lastly, we can create summary tables, and which would be as a result of some original tables. So assuming we have this table, we can group the original records by maybe the region column, and then we apply an aggregate. So assuming we wanted to find the sum of each group for the yield column. So again, let me just reload this so that you see we have a yield column in here. So we have this yield. So assuming we wanted to find the sum yield for each and every region, we can group by region, then apply the aggregate function using the aggregate the sum function using the aggregate function. And it's here in our case, we are just specifying the columns that we want to work with, and we apply that and we display the aggregated data. All right, so that's it. This particular course is quite useful, especially if you're doing work that requires you to handle data efficiently. If maybe you're a data engineer or data scientist or data analyst, yeah, we hope this will help you be able to build pipelines or solutions that allow you to use fewer resources and are able to meet the objectives of your research or your project. All the best in your learning journey. If you found this resource useful, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. Bye-bye.